Alright, good day everyone.
Good day, Mr. Paul.
Okay, today we'll be looking furthermore for second theorem. And we are at the third stage, that is the alternate segment. Alternate segment. And now, second theorem is a very important topic, especially for those of you preparing for YI, because you find a good number of YI questions coming from second theorem, both in your objective and your theory. So it's going to be, have a very good way around it. So alternate segment, this is what it talks about. Alternate segment talks about the tangent line and what? And two chords. Alternate segment talks about the tangent line and two chords. Now, you have tangent line in two cases. Where tangent line meets radius, and it creates a 90 degree. And when you see tangent line, you can answer that comes to your mind is alternate segment. Those two. And now this is a tangent. When AB is a tangent line. Now we have something like this. We have a chord here and another chord here. Now we connect them. Because your second theorem, you cannot measure your angle towards the circumference. It has to touch a line. There is nothing like this. No, it cannot happen in second theorem. It has to be connected to a line. Alright, so let's hear the C, here the D and E. Alright, now for this case, if you're asked to resolve this, you might be given here for, let me just say 55 degree, just assuming. I'm going to get down some examples. For 55 degree, you're asked, remember, for alternate segments, look at this chord. Let me make it somewhere here. Just understand something. You have your tangent line, and you have your circle this way. Now, you have a chord here and another chord here. The angle connecting with this part of the tangent line and this chord will be equal to this other angle. Hence, if here is A, here what? A. In the same way, this other angle, if it is B, we connected to, you can see this angle, this chord, it will go further to connect with what? The other angle, the other chord. You can see this chord and this chord. So by the time they create their angle, they will be connecting with the other chord. Are you with me? So where will be B? B. And if you're asked to find, let's say the W, you say what? If you know your value of this place, this plus this minus 180 will give you here. And you can see it is true. This is a 180 degree. It's straight line. Is it not true? So you have B here, you have A here. So A plus B plus W is not 180. And the same way, it's the same. So in here is 55. That will be 55. And you're giving here as let's say 70 degrees. Just making an assumption. If here were 55, they all will be 55 again. But here is other place. Here was 55 degree. Here was 55 degree. The whole of this will be 55 degree. This angle 55 degree. Then here will be 70. Connecting to this place, 70 degree. And now you have yours. You've done everything. You need your arms to find X. What will you do? You could use this angle on a straight line to find X, or you could use sum of angle in a triangle. So you say 50 plus 70. 70 plus 55 is what? If you add it, you get 125, right? 125. So you say 180 minus 125. We get our value of our X. We still got to 55. It's a coincidence. It's not like it's this place is equal to this place. So this question just led us to this point. I just made an assumption of the figures, the values. So this is what alternate segment talks about. Your tangent line and two chords. You want to always remember that. Tangent line and two chords. So you connect one chord with the other. So this tangent line and this chord will be equal to the other chord. Remember this chord. They can give you a question. Listen up. They could give you a question where you have something like this. Please don't connect this one Don't connect this one with this. This one is a separate chord on its own. You can see. This one you have here and here. Should be having something like here, this for this, then this other place for this one here. It is different. It is different. We're going to go to that solution. But knowing that alternate segments actually talks about two chords, are you with me? And your words and your tangent line. Two chords and your tangent line. Okay, here's another question. We have the circle and a tangent line. AC is a tangent line. Now, we are asked to find the value of A and B. Now, I want us to understand, name our angles. Angle A, B, E. Look at it. A, B, E is 180 or 120. A, B, E. There are two ways of writing it. Is either you put this symbol here or you put it up here. 120 degrees. If you say it like this, just note that it is the letter in the middle, and you always use capital letter to name your angles when you're looking for, when you're picking them in trees. Use the capital letter. You understand? The lowercase letter is used for angles inside. But if you're naming the angles at the exterior part, you use your what? The capital letter. The lowercase letters are the one inside. So now, is either you put it this way or like this. But remember, it is the letter in the middle that holds the value you are looking at. Look at it. A, B, E. The B is the point where your point of interest. Now, A, B, E is what? 120. The next one we have what? We have a 42 here, which is what? C, B, E. C, B, D. Sorry, look at it here. Have you seen it? C, B, D. So, angle C, B, D equals 120. Now we have, equals 22. We have that information. Now, we have to find A and B. Using our understanding of alternate segments, remember, we have two chords, this and this other one here. Now, this chord will go and connect with what? The other chord. Where's the other chord? This, and the angle it's making with the line. So this is the angle this chord is making. Is it not true? So A will be equals what? 42 degrees. A is 42 degrees. If you want to name A, you can say what? It is what? B, E, D. So it's also equals to B, E, D. B, E, D is 42. Look at it. B, E, and D. So this angle is 42. So let's get our D. Our B. Angle B here could be seen as what? B, D, E. We will call it angle B. It also equals to B, D, E. Remember, you can put your cap up here. You can put your cap up here. Also equals to what? Which equals to what? 120. Remember, alternate segments. 120. So this is what alternate segment talks about. Now, you have here 120 degrees. You have here 42. If you are to look for this place, what will you do? Sum these two. Is that use sum of angle in a triangle, or what would you use? Angle on the straight line. So 120 plus 42 is what? 162. Subtract it from 180, you get 18. So this place has also been attended to. So 42, 120, and 18. Any question?